Okay, today we're going to spend some time reviewing how to find different angles and circles based upon where their vertex is. So let's write those formulas down first just to review. Remember, if the vertex is in the center, then the formula is that the arc and the angle are congruent. Okay, if your vertex is on the circle, then we take the arc, divide it by 2, and that gives us the measure of the angle. If our vertex is in the circle, but not the center, then we have the vertical angle scenario where we take both our arcs and we add them together, divide by 2, and that gives us the angle. And I'll show you what I mean by vertical angles here in a minute when we get to one of those. And the last one is when the vertex is outside the circle. We take our big arc minus our small arc, cut that in half, and that gives us the measure of the angle. So we're going to be using all 4 of these formulas, but a review that could also help you out with these are remembering the words vertical angles and linear pairs. So let's do a quick review there. So if I have vertical angles, remember you have some intersecting lines and they're across from each other. So it could be these two or it even could be these two. And remember, if you have vertical angles, they are congruent. So if you see a set of vertical angles, use that to your advantage and go ahead and get that answer out of the way. The other word that you could use to your advantage is knowing and remembering about linear pair. Remember, they make a straight line, they're adjacent, and they're going to always add up to 180 degrees. So sometimes these two words can help you solve these angles without having to use the arc formulas. Now, the next piece of information that you always need to pay attention to are the directions, because they're going to give you lots of information to help you label your circle to get started. So the first one is that line AB is tangent to circle O. We learned that formula, the theorem, back at the very beginning, where if we have a tangent line and it meets up with a radius or diameter, remember those two lines are perpendicular. So right off the bat, we now know that angle 7 is a right angle. We don't have to do a formula for that. We can, but we don't have to, knowing that theorem, knowing that those two are always going to make a right angle. So let's go ahead and get angle 7 out of the way. And I'll show you another option if you forget that theorem in a minute once we get to angle 7. The next thing is AF, line segment AF, is a diameter. And the reason that's important here is because that cuts your circle in half. That means that all of these arcs add up to 180 and all of these add up to 180. So that's going to help us find our missing pieces here in a minute. So the first arc they gave us is arc AG, knowing that that is 100, so go ahead and label. Next one is CE, is 30 degrees. So I'm going to go ahead and label that. And EF is 25. Now let's use that statement we just talked about with the diameter to find this missing arc and this one. Remember, we have 2 semicircles, which will help us find those missing pieces. So if this is 100, that's going to be 80 right off the bat, because 180 minus 100 gives us 80. If we were to add these two up, 30 and 25 gives us 55. Take that away from 180, and that gives us 125. So now we have all of our missing pieces. I advise to go ahead and do that so that this next part becomes really easy. You can just plug into the formulas and go. So looking at angle 1, if we highlight it, angle 1's vertex is in the center, so we'll use our formula for a central angle where the arc and the angle are the same thing. So if the arc is 80, so is the measure of the angle. So we know that that is 80. And to show some work, I'm just going to write here that the vertex was in the center so that I knew that those two were congruent. The next one is angle 2. And angle 2 is right here, another central angle. And there are 2 options here. You can use the central angle formula, which makes it really easy since those two are congruent. Or, since you know angle 1, you know that 1 and 2 are a linear pair, you could just subtract from 180. So either way you want to do it works for me. So we can write here that that is 100 And we can say for work that we used our central angle, or we could use a linear pair here. All right, now let's move on to angle 3. Angle 3 is right here. And we can see that angle 3's vertex is on the circle. So when we use our formulas here, on the circle is arc divided by 2, gives me my angle. So if we look at angle 3 opens up all this way. So it opens up to both of those arcs. So if we add those together, 30 and 25, we have the measure of our arc divided by 2. So we can say here 55 divided by 2, and that's going to give us 27.5. And I'm also going to put here in parentheses that we used the formula for on. Okay, let's see if I can get this erased. Now we're moving on to angle 4. Angle 4 is right here. And we can see that angle 4 is in the circle, but not in the center. So if it's in the circle and not in the center, we need 2 arcs, arc plus arc divided by 2. So we know 1 arc here is 80. But remember, for the in formula, we need 2, so we have to go to its vertical angle, which is right here, and look at that. So if I highlight here, there's its vertical angle. We can see that it opens up all of that. So we have to put together the 125 and the 30 together to make that angle. So I'm going to write here that we're going to use the formula for in. And our first arc was 80. Plus our second arc, those two combined, so 125 and 30, which gives me 155. And we divide that by 2, and that's going to give us 117.5 degrees. All right, I'm going to change color of my highlighter so that you can start to see, otherwise I'm going to erase everything. Angle 5 is right here. So we have 2 options here. We can do another in formula and work with the arcs and all of that. Or if we already know what angle 4 is, we know 4 and 5 are a linear pair, let's just subtract those from 180, and that way you can see that option too. So I'm going to use linear pair. And I'm going to say 180 minus what we found for 4, because those are a linear pair, and that would give us 62.5 degrees. All right. Angle 6. Angle 6, I kind of covered it up here, but angle 6 is out here. And we can see it's all of this. And the reason that I highlight this is so that we can see the big arc and the small arc. And we have both of those. The big arc is 100, the small arc is 30, because remember our formula for out is big arc minus small arc. So we could say here, big was 100. Minus our small arc of 30 divided by 2, and that would give me 35 degrees. Now, we said at the very beginning this was 9 degrees because of this theorem that we learned, but another way to look at that is, remember, angle 7 is has a vertex that's on the circle. Remember, that's arc divided by 2. Well, the arc for angle 7 goes all the way here, which is a semicircle, 180. 180 divided by 2 is another reason that that equals 90 degrees. Last one here, angle 8. So angle 8, we can see is an angle that is on the circle. Let me highlight with a different color here. Angle 8 is on the circle. And so if it's on, remember, arc divided by 2, we can see that angle 8 opens up to this angle here, that 125. So all we have to do for that one, so I'm going to write on, remember what formula, and we can say 125 divided by 2, and that gives me 62.5 degrees. So as you're working on this, just find all your missing arcs first, make sure you have your formulas, look for vertical angles and linear pair to help simplify it down a little bit for you, and then just start finding your angles. It's just a big puzzle.